Today our discussion will go on what is IBM WebSphere MQ, what it can do. IBM WebSphere MQ built on Java. It is platform independent. Supports 80+ platforms. It is an IBM middleware message transport product. It enables communication between distributed applications over the network. MQ stands for messaging and queuing. It is a framework. Messaging is the mechanism to define data as message to exchange over the network. Queuing is the mechanism to hold data as messages until unless processed by remote service. WebSphere MQ, known as an integration engine, it integrates distributed applications irrespective of the programming language, platform, and protocol. For that, it provides an interface. It is MQ API. Developers need to know implementation of MQ API to communicate other applications by exchanging data as messages over IBM MQ servers. Look at here, Satish. Two distributed systems are hosted here. One is Windows and one is Linux. This is Windows host. This is Linux host. On Windows host, an application hosted. Its name is Business Service. This application might develop in C programming language, or in C++, or in Java, or in .NET. One more application hosted on Linux. Its name is Business Operation. This application might develop in C programming language, or in C++, Java, or in .NET. In between distributed applications, we wish to enable reliable messaging. For that, we integrate these distributed applications by configuring an integration engine. It is IBM MQ server. Here IBM MQ server provides MQ API irrespective of the programming language. It is an interface. Programmers need to know implementation of MQ API. Then programs can create MQ messages with message data. Message is collection of data or representation of data. MQ message consists two parts. They are MQMD header and the payload. Payload known as message body. Message body contains business data. The data might available as text, binary, XML, non-XML. See, my business service wants to communicate with business operation, business service creates MQ message with message data. It connects IBM MQ server. It puts message in queue. Queue is an object in MQ series. It is file and data structure. It is container. It holds messages. Put is nothing but write. Other end application is available on online. It connects IBM MQ server. It gets data on queue. Get is nothing but read. On MQ server, major operations are put and get. An application deposits data as messages in queue. An application draws the data from that queue. IBM MQ server or IBM WebSphere MQ, known as store and forward mechanism with assured delivery. It is just like passbook. Yeah, Satish, you know very well about bank passbook. In our bank passbook, what the transactions we can see? Debit, credit. If we deposit, they credit. If we withdraw, they debit, right? No other transactions in that passbook. These two types of entries we can see, right? Here also the same. An application puts data, an application gets data. When an application puts data as messages into it holds until unless processed by remote application. When an application gets the data from MQ server, the data no more. Yes, Mahit, are you clear about this?
Yes, so far.
IBM MQ server can route the data. It cannot transform the data. Okay. Listen me. I repeat the statements. IBM WebSphere MQ built on Java. It is platform independent. It supports 80 plus platforms. IBM WebSphere MQ is an IBM middleware message transport product. It enables communication between distributed applications over the network. It is an integration engine. It integrates distributed applications irrespective of the platform, programming language, and protocol by providing an interface MQ API. It is also known as store and forward mechanism with assured delivery. On MQ server, major operations are put and get. Just here it can route the data. It cannot transform the data. If you compare IBM MQ server with DB engine, easy to understand, Satish. In DB engine, we create tables to hold data as records permanently. Whereas in MQ server, we create queues to hold data as messages temporarily. Okay. Look at here. Let me open this PPT here. Look at this. See here we integrated business service and business operation programs over the network with the help of IBM MQ server. Whenever my business service wants to exchange its data with business operation, it defines data as messages. It connects MQ server. It puts messages in queue. Queue is the only resource in MQ server to hold data or to hold messages. Whenever remote service requests the data, queue forwards. When an application draws the data from MQ server, the data no more. Okay. Here applications exchange data as messages. MQ message consists two parts. They are MQMD header and message body. Message body known as payload. MQMD stands for MQ message descriptor. MQ message descriptor contains metadata about that message. Metadata is nothing but it represents it holds message ID, message expiry information, persistence information, message type, which application created that message, on which date, at what time application created that message. This kind of metadata contained by MQMD header. The message body holds actual data. It might available as XML data. It might available as text data. It might available as binary data. It might be anything. IBM MQ server does not create messages. It does not define any data in message body. An application creates message, but message is consumed by another application. Just IBM MQ server can route the data. Just it can hold, it can store and forward the messages to remote services. Okay. See here you can see the message parts clearly. Message descriptor here to here. At last you can see the message body. Okay, right. Already I said in DB engine we create tables to hold data as records, whereas in MQ server we create queues to hold data as messages until processed by other end application. See sender end application sending messages to Q1 and to Q2 as messages. In between these two resource managers, an application available, it is J2E application. It's connected IBM MQ server and it's connected DB engine. It is going to get messages from MQ server. It inserts the data as records into tables in the database. See? In MQ server, data stored as messages. These messages are retrieved by IBM MQ server. Just inserted as records into tables, right? Once if you insert the data into the tables, n number of times you can export until you delete. But whereas in MQ server, once if you retrieve the messages no more. Here it supports once and only once delivery and guaranteed delivery. Okay. Look at here what IBM says about MQ once and only once delivery and guaranteed delivery. Java nothing but an object, right? So in MQ series, everything we create as an object. In MQ series, objects are predefined. MQ predefined objects are 7. They are queue manager, queue, channel, listener, process, name list, and service. We create MQ objects with unique names. To define names to MQ object, MQ series allowed char set is A to Z capital, A to Z small, 0 to 9 digits. Allowed special characters are dot, slash, mod, underscore. This is the only char set allowed by IBM WebSphere MQ to define names to MQ objects. There is a limitation about object name length. Object name length can be less than or equal to 48 characters except channel. Channel name can have less than or equal to 20 characters. Except channel name, all the object names length can be less than or equal to 48 characters. To administrate MQ predefined objects, in MQ series, predefined commands available. MQ predefined commands are broadly divided into three types. There are control commands, MQSC commands, and PCF commands. Here MQSC stands for MQ script commands. PCF stands for programmable command format commands. As a WMQ system admin, you work with control commands and MQSC commands. You don't work with PCF commands. PCF commands are used by MQ applications to create dynamic queues in MQ server at runtime dynamically. So we work with control commands and MQSC commands. Control commands are around 25. MQSC commands are only 40. Control commands we execute at OS level. MQSC commands we execute at MQ server level. With the help of these three types of predefined commands, we administrate these 7 objects. What is mean by administration? Create objects, delete objects, modify object definitions, start services, stop services. These are all the comes under administration, right? So we administrate these 7 objects with the help of these 3 types of predefined commands. Okay, right. As you know, hardware, operating system, hardware, operating system. Your operating system is Windows. On this Windows platform, we install Windows MQ. Once MQ is installed on Windows, it runs as a service. On top of this, we host MQ objects. In these 7 predefined MQ objects, Queue Manager is an initial object and first and foremost object in MQ series. Unless we create Queue Manager, we cannot create rest of the MQ objects. Queue Manager itself, MQ server and MQ engine. It is subsystem. It controls and holds all the MQ predefined objects. It provides queuing services to the application. It is single point of contact to all the distributed applications to access MQ queues to perform put and get operations. Look at here, Satish. Once Queue Manager object is created, in its control, we can create rest of the MQ objects. Okay. Here I create queue, channel, listener, process, nameless, and service. Where we define all the MQ predefined objects in queue manager control, right? It is owner of the MQ objects. If an application wants to put messages in queue, or if an application wants to get messages from queue, it must connect the queue manager. Then only it can access the queue. Connect, open queue, perform put or get, close the queue, disconnect from queue manager. In this sequence, MQ applications perform operations on MQ server. Okay. As a WMQ system admin, you install IBM MQ, you host MQ objects, and you grant, revoke authorities to client user IDs. We don't implement MQ API. Developers are take care implementation of MQ API. I will show you some sample programs how they implement. See here, go to samples directory.
Madhu, can you explain that our communication between queue and channel and listener, those things?
Yeah, about all those objects, we can explain in particular mechanisms only. If we explain now, it's not me.
Okay, then no problem.
Listener service listens inbound connection requests at queue manager. Channel transports the message between two MQ servers. Okay. They are for different purposes. Today just concentrate only on queue manager and queue.
Okay.
Hiram, can you read this selected statement?
Sample C program that asynchronously puts message to a message queue.
Right. This is C program. They implement MQ API. Can you see this? Includes for MQI, MQ interface, right? That MQ interface available as header file. Can you read out this, Sairam?
Connect to queue manager.
Program has to connect queue manager to access the queue. So to connect the queue manager, application executes function MQ call. Okay. Is MQ API call. Right. Program makes connection on queue manager. After that, it has to access the queue, right? Can you read this?
Yeah, open the target message queue for output.
Queue is file. Queue is file. Application must open that file to perform a put or get. So to open the queue, what is the function? This program executes when you open, right? After that, it creates message. It creates MQ message. To put message in queue, it executes MQ put function. After performing put, it closes the target queue. To close the target queue, program executes MQ close. If application wants to disconnect from queue manager, it disconnects like this, MQ dis. Here we must observe the sequence. MQ con, connect the queue manager. MQ open, open the queue. Perform either put or get. Then close the queue. Disconnect from queue manager. Okay. In this sequence only, all the MQ applications perform operations on MQ server.
Is this coding written in the application?
Yeah.
Okay.
Yes. Yes, please. Any query?
And what do you call it? Like, do you call these functions or these are commands?
See, in C programming language, we say as function. In Java, we say as method. In our MQ perspective, we say as MQ API calls. Okay.
Okay.
Look at here. IBM WebSphere MQ provides MQ API as jar file to C programming language. Java developer keeps the jar in his class path, imports all the MQ API packages, right? He starts implementation. Can you read this statement here in the main method?
Create a connection to the queue manager.
Yes, program very first opens the connection on queue manager. Then queue. Here define a simple WebSphere MQ message. To put message in queue dot put, right? This is OOPS language, so the operation sequence is the same, operations are the same, but way of writing the code somewhat different. Okay. To get message, what is the method? Q.get. It is nothing but MQ get. If application wants to close the queue, Q.close. It is nothing but MQ close. If application wants to disconnect from queue manager dot disconnect. It is nothing but MQ disk. Okay. Open connection on queue manager, access queue, perform either put or get, close the queue and disconnect from queue manager. Okay. This is how developers implement MQ API. Then programs can define data as messages. They can put in MQ server. Other end application can get all those messages from MQ server. Okay. Any program can communicate with any program here, irrespective of the programming language. Yes, any queries, let me know. If you see outline of MQ series, here available number of objects are 7. 7 objects, 40 predefined commands, major operations on MQ server are put and get. Queues are going to hold messages. The data comes as messages, right? This is the outline of MQ series. 7 objects, 40 predefined commands. Queues will available to hold data as messages. On queues, applications perform put and get. Nothing here. Okay.